Okay, a video showing you now how to work out two very basic calculations for two different sectors of circles where I'm going to ask us to work out the arc length S and the area A. In each case I'm simply going to give you the radius and the size of the angle. I'll show you how ridiculously easy these are. So if I want to work out what the arc length is, we apply the formula S equals r theta. S is what I'm trying to find, the arc length. I don't know how long the arc length S is, but I do know what the radius is, it's 2 meters, and I do know what theta is, and it must be in rads, remember, to use this formula, and it is given in rads as pi by 3. So we've got two lots of pi by 3, and if you think about it, I didn't really need to write the bracket in there, it's just going to be 2 pi by 3 meters. Notice I'm leaving that pi in the answer, and you are perfectly entitled, in fact it's probably best to leave the answer as 2 pi by 3 meters. If the question says give it to 2 decimal places, you'd simply change pi on your calculator to approximately 3.14, or use your pi button and work out 2 times 3.14 share by 3 and write down the decimal answer. But I'm going to leave it like that. Now the area of that sector is equally easy. You just quote half r squared theta, which is the formula I derived in a previous video, and you substitute in the values. So the area is going to be a half times the radius is 2, so that's going to be 2 squared, times by theta in rads, and theta in rads is pi by 3. So we get that to work out. So we just sort this out now. 2 squared is 4, half of 4 is 2, and so 2 times pi by 3, you get again the same answer by chance, 2 pi by 3, but this time we're in meters squares. These are just coincidental, the same value. They won't always work out to be the same value. So there you go, there's the first answer, there's the arc length, and there's the area for this particular question. Very straightforward substitution. Number 2 is also straightforward, but it's got a slight twist. Notice in 2, if we want to work out the arc length, we're going to use S equals r theta again, but theta is the angle in radians of the sector. Now that is the angle inside the sector, not what is given, which is the exterior angle. So what you've got to do is work out first what that angle is. It's very straightforward. You know, in a complete circle, all the way around, it's going to be 2 pi rads. Now 2 pi rads, if you think about it, if we use a bit of LCM work, because this fraction is given over 4, I'm going to convert 2 pi to 8 pi over 4. So 8 quarters is the same as 2 whole ones. So the whole way round is 8 pi over 4. If that is 7 pi over 4, then that must be 1 pi over 4. So that angle inside the sector, which is what we need, is going to be pi by 4 rads. And that is the first thing you must do to be able to work out what the arc length is. Now, arc length S of the sector then will be the radius, that's given 10, times by theta inside the sector is pi by 4. So you get 10 pi by 4. That will cancel down, share by 2 you get 5, share by 2 you get 5 pi by 2, and units meters. If the units were in centimeters, we'd put centimeters. Again, leave pi in your answer unless you're told otherwise, in which case you could change pi to 3.14 and work it out on a calculator. The area of this particular sector will be, from the formula, a half r squared theta. A will be equal to, if I move this up a little bit, a half times, now the radius is 10, so you got 10 squared, which will be 100 in a minute, times theta, which is pi by 4. So you get A equals 10 squared is 100, share by 2, that's 50, 50 over 4, which is 25 over 2 if you cancel it. So you get 25 over 2 pi, or 25 pi over 2, same thing, and we're in meters squares. Notice this time the answers are not the same, and obviously the last time that was just a coincidence that they were the same. So there you go, there's the area in that case. So just be careful when you're doing this time, make sure that the angle given is inside the shape, and if it's not inside the shape, do this sort of LCM calculation, 7 pi by 4, that must be 1 pi by 4 inside the sector. So two very basic examples of how you apply s equals r theta and a equals a half r squared theta.